Okay, so we are ready to take data. Just a couple of modifications here. First thing I did is over here on the output of the Tach. Remember before we just had it going over to the oscilloscope here, which is fine, still going in there. But now what I've done on the Tach is I've teed off its output. One cable is still going to the oscilloscope, and the other cable over here, I'm going to route over to this counter timer system over here, which just counts. So every time it sees one of these pulses from the time to amplitude converter, what that means is a pulse pair has been seen that existed between 0 and 10 microseconds between the pulses. In other words, a pulse pair came in that did have a time between them between 0 and 10 microseconds, which is what the Tach is discriminating against. And so what that essentially does, we know that every time a pulse appears, a pulse pair must have happened that were within 10 microseconds of one another. That's what I was trying to say the whole time. And we'll just count how many times that happens over here, and that'll be an indicator of how many muons we think we've detected. Because again, every time we see a pulse pair must have been between 0 and 10 microseconds. So if you just count these pulses, that in principle will be the number of muons you've detected, and off we go. So at the moment, just to show you sort of how that works, if I start the timer out, let me just stop, reset, and start counting. So it starts counting like crazy, and these aren't muons, because remember, I still have the LED flashing inside the scintillation thing there. And that's the value of having that LED in there. It allows us to just see the data throughput and the signal throughput and just test everything and get that calibration at a very high rate, 1 kilohertz, without having to wait for actual muons to come in. Okay, so here's my favorite part of the experiment. To start counting muons, guess what you have to do? Just one thing. Right, just pull the LED off. Just pull it off like that. Reset the counter timer over here. And I'll also just sort of go off camera here and I'll reset the computer. Clear the computer out. And we're going. So all I did was pull that LED flasher off. And we're just waiting now. And so you can see there is some activity on the oscilloscope. There are some pulses coming in. I don't know what it is, most likely noise. But obviously it wasn't the pulses coming in. There was no pair between 0 and 10 microseconds, so the time to amplitude converter is not counting those as muons. Well, it'd be a pulse and then a pulse some hundreds of microseconds later, another pulse. So there's plenty of activity, but no muons yet. So I don't know if I'm crazy to do this or not, but I think I'm just going to sit here with you in this video, at least until we see the first muon come in. And again, when the first muon comes in, we'll also expect that the computer will have histogrammed it properly in PHA mode, and it's going to start to build up our muon lifetime profile that we can use for analysis. So believe it or not, this is actually what you mostly do on this experiment. After you figure all the cabling out, you just wait.